All right, this is topic 11-1, area and perimeter of rectangles and parallelograms. You need to refer to your fact sheet for the formulas. But for a rectangle, you've known this for a long time, but to find perimeter of a rectangle, you do 2 times the length plus 2 times the width, because we know opposite sides are congruent. And for area, we do length times width. So obviously you've been doing that for a long time, so we're going to be going a little more in depth and using our geometry skills to help us find length and width. So at number 1, the length and width are given to us. But so for the perimeter, we're going to do 2 times 5 square root of 2 plus 2 times 4 square root of 2, and then add those together. So that gives us 10 square root of 2 plus 8 square root of 2. And because those are like terms, they have the same radical, then we can add those together and we get 18 square root of 2. Now there's no units on this rectangle, but I'm going to go ahead and write units, so when there are, I won't forget to do it. And then of course to find the area of the rectangle, we're going to do length times width, so 5 square root of 2 times 4 square root of 2. We multiply what's on the outside together, which is 20. We multiply what's on the inside together, which is 4, but remember that square root of 4 is just 2. A radical times itself just gives you that number, so 20 times 2 would be 40. And remember that perimeter is the distance around a figure and area is the number of square units inside a figure. So that would be 40 units squared. Okay, now for number 2, we don't know the length or the width of this rectangle, but we know the length of the diagonal is 4. And you probably noticed that there is a 30-degree angle right there. So that means that this is a 30, 60, 90 right triangle. You might want to find that fact sheet and look that up if you've forgotten what to do. But remember that across from the 30 is x, across from 60 is x squared of 3, and the hypotenuse is 2x. So if that's the case, 2x equals 4, then we know that x equals 2. So our width is 2, and then we just plug that in place of x here, and our length is 2 square root of 3. So for the area, we would do length times width, which would be 2 square root of 3 times 2, and that gives us 4 square root of 3, again no units, so that would be units squared. And then for our perimeter, we're going to do 2 times the length plus 2 times the width. And this time, they're not both square roots, so we cannot add those together. So we get 4 square root of 3 plus 4, and it doesn't say to round unless it specifies and says to round. We're going to leave it in exact form. This is the exact value of the perimeter, 4 square root of 3 plus 4 units. Okay. All right, number 3. Again, looks like we have some measurements. We have the diagonal is 10 and the length is 8, but we don't know the width. So in this case, it doesn't say 30, 60, 90 or 45, 45, 90, but we know 2 of the sides. So you can do Pythagorean theorem to find your other side, but hopefully you recognize that triple. This would be a 6, 8, 10 right triangle. That's a multiple of 3, 4, 5. You need to memorize, remember, your basic Pythagorean triples. So, or you can do Pythagorean theorem and work it out. So my area is going to be length times width, which would be 48. In this case, we have inches, so this would be inches squared. And then my perimeter is going to be 2 times 8 plus 2 times 6, or 12 plus 16, which would be 28 inches. All right, number 4 says a square with a diagonal of 6. So I'm going to draw my square. I know all the sides are equal from the last unit, and my diagonal is 6. And I know the diagonal bisects opposite angles. So I know this is 45. So that's a 45, 45, 90 triangle. So if you need to look at your old fact sheet, this would be unit 8. Then look it up. But remember, our legs are congruent, and the hypotenuse would be x times the square root of 2. So if we know x squared of 2 equals 6, then we want to divide by the square root of 2 to get the side length, or to find x. And so we have 6 divided by the square root of 2. But remember, we can't leave it like that, so we rationalize it. We shove the radical up to the top and leave it on the bottom. Remember, by multiplying top and bottom by square root of 2. And then we can simplify that and we get 3 square root of 2 for the side length. Okay, so for the area, we're going to do 3 square root of 2 times 3 square root of 2, or 3 square root of 2 squared. Be careful if you're punching that in the calculator. If you don't put that in parentheses, it's only going to square the radical. You want it to square the whole thing. Or you should know 3 times 3 is 9. Square root of 2 times square root of 2 is 2, so 9 times 2 gives you 18. Again, no units, so units squared. And then the perimeter, we would just do 4 times the side length, and so that gives me 12 square root of 2 units. Okay, so similarly, number 5, same thing, but this time it's a little bit nicer. We know this is a square, that's 45, 45, 90. And this time the diagonal is 4 square root of 2. So when you divide by the square root of 2, it cancels on each side, or you can just look at that and see that the side length should be 4. So area is 16 units squared, and the perimeter is 16 units. All right, so that's rectangles and squares. Now let's talk about parallelograms. If you look at this picture up here, you've got a parallelogram with the height drawn in, and the height is always perpendicular to the base. If you were to cut that parallelogram along the dotted line and move this triangle over to the other side, then what figure do you make? You make a rectangle. And so in this case, we just learned the area of a rectangle is length times width, and in that picture, the length is the base and the width is the height. So to find the area of a parallelogram, you do base times height. And then for the perimeter, you can do kind of the same thing with as the rectangle, because opposite sides are congruent. Or you can just add up all the sides, of course. All right, so for this parallelogram, what's my base? 12. What's my height? Not 5, but 4. It's the distance perpendicular to the base, or the extension of the base. So the area would be 12 times 4, which is 48, and we do have meters in this case, so 48 meters squared. And then the perimeter would be 8 plus 24, sorry, 10 plus 24. When you're finding the perimeter, make sure you're adding up the sides. You're not using this for the perimeter. So that would be 34 meters. Okay. All right, so number 7, a little bit different. We've got the base is 10, but we don't know our height. So we know this side is 10 and this is 8, and we've got a 45, 45, 90. So once again, the hypotenuse is x squared of 2. You might have forgotten our shortcut when we did Unit 8, but when you divide by the square root of 2 and then you rationalize it, you're going to get 8 square root of 2 over 2. So the shortcut, remember, is to take 8, if you've got a whole number, divide that by 2, and then put it on the square root of 2. So that would be the height of our parallelogram. So for the area, we're going to do base 10 times the height, 4 square root of 2, so we get 40 square root of 2 units squared. And then for the perimeter, 10 plus 10, 20, plus 16, 36. So we get 36 units. All right, number 8. Same type of thing. We know all the sides, so we can get the perimeter. The perimeter is going to be 12 plus 8, which would be 20. No units here, so 20 units. And then for our area, we've got a 30, 60, 90. So my hypotenuse, remember, is 2x. That means x equals 2. That's across from the 30. So this is 2, and across from the 60 is going to be 2 square root of 3. So to get the area, you're going to do base times height. So it's going to be 6 times 2 square root of 3, which is 12 square root of 3 units squared. Okay. All right, last problem says find the perimeter of this parallelogram. So I have a parallelogram on the coordinate plane. We could prove it's a parallelogram by showing the opposite sides are parallel. But if we want to find the perimeter, we need to know the lengths of the sides. And so what do we do to find lengths of sides in the coordinate plane? We need to do distance formula. Okay, so let's write down our points. We've got L is negative 5, 2. M is 3 at 3, 6. O is at negative 7, negative 3. And N is at 1, 1. All right, now do we need to find the length of all four sides? No, because in a parallelogram, we know that opposite sides are congruent. So I'm just going to find the length of two of the sides, and then, of course, multiply each one by 2, and then add them all together. So I'm going to find the length of OL. So remember in distance formula, or you can make a right triangle out of it. That's where distance formula comes from. You can make a right triangle out of it. That's 2 squared plus 1, 2, 3, 4, 5 squared. Or you can subtract your x's for O and L, subtract your y's for O and L, and that's what you're going to get. And then take the square root of that, and so that gives us the square root of 29. Okay? All right, and then I'm going to find LM, because I know MN is the same as OL. And again, if you don't want to use distance formula, this is where distance formula comes from. You can make yourself, whoops, wrong one, sorry. You can make yourself a right triangle to find the length of LM. And so one side is 4 units, so it'd be 4 squared, and the other side is 8 units. So that'd be 8 squared. Take this, add those together and take the square root. That gives us the square root of 80, and that simplifies to 4 square root of 5. So for my perimeter, I'm going to do 2 times the square root of 29 plus 2 times 4 square root of 5. Those radicals are not the same, so you can't add them together. So I'm just going to leave it in exact form, would be 2 square root of 29 plus 8 square root of 5 units. Okay, so use distance formula or draw a right triangle to do Pythagorean theorem to find lengths on the coordinate plane.